Hello, it's me again. Welcome to the video on differentiating with the product rule. In this video, we develop the technique of forming a gradient function using 6 short steps to differentiate a function which has been formed when two other functions are multiplied together, and we can't undo that multiplication easily to separate them. As noted in the introduction to the chain rule video, we can differentiate functions in many ways, depending on the structure of the function we are addressing and the nature of the components in it. The product rule for differentiation is used when, after we look at the structure on the right-hand side of the equation, we see that there are two terms or functions in the pronumeral, say x, which are multiplied together, and at least one of these terms has brackets, probably raised to a power. Typical equations to which the product rule technique could be applied are y equals x to the fourth times x minus 3 all cubed, or where we have two brackets raised to powers, x plus 3 all squared times 3x minus 1 all to the fourth. Or we might have a radical, y is equal to x times the square root of 1 minus x. Now let's take the first of those equations. Y is equal to x to the fourth times x minus 3 all cubed. We have two subfunctions multiplied together, and it's pretty hard to untangle those because it would take us too long. So it's perfect fodder for the product rule. So step 1, write down the two terms in order. So x to the fourth with a little bit of a break to x minus 3 all cubed. Step 2, write each derivative under the relevant term. So x to the fourth differentiates to 4x cubed, and x minus 3 all cubed, the 3 comes down the front, rewrite the brackets, take 1 off the index and multiply by the derivative, which is 1. So we have 3 bracket x minus 3 all squared. Now we always start in the top right corner and we multiply the top right term by the lower left term. So 4x cubed times x minus 3 all cubed. A product is just like adding many times, so now we write down a plus sign after the bracket, and we always do that. Then we multiply the top left term by the lower right term. So dy dx is equal to what we had before with the plus, and then x to the fourth times 3 bracket x minus 3 all squared. And now the only other job we have is to tidy up. So we can factorise out an x cubed and an x minus 3 all squared. So we're left with x cubed times x minus 3 all squared times 7x minus 12. Very easy, no formulas, nothing to forget. So we just feel our way through all of those steps every single time. Second example. Perfect situation for a product rule. We have two functions, both of them are in brackets and raised to a power. So we've got x plus 3 all squared times, important, 3x minus 1 all to the fourth. So we're going to follow exactly the same steps, and that's why I've left them there to emphasise that there's nothing different. No formulas, just these steps. So write the two terms in order, x plus 3 all squared, little space, 3x minus 1 to the fourth. Now write the derivative of each under the relevant term. They're both chain rules. So 2 comes down the front, we rewrite the bracket, take 1 off, multiplied by the derivative of 1. So it's 2x plus 3. And then the other one is exactly the same, 4 in brackets, 3x minus 1 cubed. Then all times 3 for the derivative. We're going to start in the top right hand corner and multiply the top right term by the lower left term. So we have 3x minus 1 to the fourth times 2 outside of x plus 3. A product is just like adding, so we put a plus sign in. And we multiply the top left term by the lower right term. So we have x plus 3 all squared. Take the opportunity to multiply the 4 by the 3. So we have 12 outside of 3x minus 1 cubed. And then we just tidy up. We can take out common factors, so the 2 comes out of both terms, an x plus 3 term comes out of both, and a 3x minus 1 cubed comes out of both, and we're left with that stuff in brackets. And so we can simplify that to 2 outside of x plus 3, 3x minus 1 cubed times 9x plus 17. Always the same steps. Third example, perfect situation for a product rule. We have two functions, an x and a square root of 1 minus x, multiplied together. We're not going to be able to separate those two easily, so we've got a product rule to do using exactly the same steps as we always do. Step 1, write the two terms in order. X, and instead of writing the radical, we're going to use the index of a half so we can access it easily. Derivative in step 2, derivative of x is 1. Derivative of the second term, bring the half down the front. We rewrite the brackets, 1 minus x. We take 1 off the index, a half goes to minus a half, and then we multiply by the derivative of what's inside the brackets, which is going to be minus 1. Then we always start in the top right hand corner, no change. So multiply, we've got 1 times the square root of 1 minus x. Now I'm going to use the radical there because I want to be able to look at it. Looks pretty good. Product is just adding many times, put it on the plus sign. Multiply the top left term by the lower right term, so we have x times minus a half times 1 minus x all to the minus a half. So we now tidy up and we write our radical down so that we can see it again. So we've got the square root of 1 minus x over 2 times the square root of 1 minus x. And now I can see when I take that denominator up to the numerator in the left-hand side, left-hand term, I can see that it's going to cancel out. Nice to be able to see that. So multiply it out. We've got 2 times 1, which is 2, minus 2x, and then the second x goes in there, minus x. 2 minus 3x over 2 times the square root of 1 minus x. Straightforward, got over any problems, and we always followed the same steps. Now we can have a quick summary, and therefore we don't need our steps, so we'll slowly fade them out so we can talk about other things. So the product rule is used when we have to differentiate a function which has two functions in the independent variable, and these are multiplied together. So we're always going to look at a function that we're given to differentiate and think structure. For a product rule, it looks like two functions multiplied together. These are the steps that we've had before, and we're going to write them down and put them in our revision notes and follow them every time. If you follow them every time, no problem. You now have the steps to follow when you need to differentiate a function with the product rule. It is important we set out our work nicely and we follow our steps. Hope the repetition has led to you feeling confident in using these steps to determine a gradient function. Thanks for watching this video. The next video explains the use of the quotient rule for differentiating a different format again for functions. Hit the like button and subscribe if you haven't already. Also go and do some questions on the product rule, Test Yourself 1, on my website at drjaysmaths.com. Add a comment below and send me an email if you have any questions. Good luck. See you in the quotient rule.